All right, let's jump right in. We're heading into the world of mathematics, but forget about calculators and long equations. Nope. Today, we're putting on our detective hats because we're about to investigate a mystery, a real mystery that lies right at the very heart of logic itself. So just think about this for a second. What if a mathematical proof, the thing we all consider the absolute bedrock of certainty, was actually a crime scene? Imagine a place where something crucial is proven to exist, but it's just gone, vanished into thin air. Which, of course, brings us to our case file. We're calling this one the case of the witness. And this is a real mathematical whodunit. Seriously, it's not just some abstract puzzle. It's a genuine mystery that has kept logicians and computer scientists totally hooked for decades. Okay, so to really get what's going on here, we first need to understand what's missing. And in the world of mathematical proofs, the thing that's missing is called an effective witness. Now, you can think of the witness as the smoking gun. It's the hard evidence. So if a proof says, hey, there's a number out there with this very specific property, the witness is the proof actually holding up that exact number and shouting, here it is, I found it. It's the concrete proof you can hold in your hand. But here's the problem. Sometimes we show up at the crime scene, and this is what we find. A non-effective proof. Now, everything about it looks right. The logic is totally sound, the argument is flawless, and the conclusion is certain. A witness absolutely has to exist. It's like the detective. Our proof comes up to us and says, case closed. But then you look around, and the actual evidence, the witness, is just gone, nowhere to be found. So you're left scratching your head thinking, wait, how is that even possible? Well, like any good detective story, to solve this mystery, we've got to identify the usual suspect, right? There's a very specific method, a particular way of thinking, that actually allows these witnessless proofs to even exist in the first place. And here's our culprit. The main method is this super powerful but kind of sneaky tool from classical logic called reductio ad absurdum. You probably know it as proof by contradiction. So here's how it works. You basically say, okay, let's just pretend for a second that the thing I'm trying to prove is actually false. Then you follow that logic, and if it leads you to something completely ridiculous, a total absurd contradiction, well, that means your starting assumption had to be wrong, which in turn means the thing you wanted to prove must be true. It's honestly brilliant, but it's also the very reason our witness goes missing.
So this whole thing basically creates two very different kinds of detectives, or proofs. On one hand, you've got your constructive proof. Think of this one like a chef giving you a recipe. It shows you exactly how to build the witness, step by step. Here's how you bake the cake. Simple, direct. But then you have the non-constructive proof, our main suspect. This one's way different. It's like walking into a kitchen that's an absolute disaster and saying, well, a cake must exist in this universe. Why? Because if a cake didn't exist, this kitchen would be spotless. And just look at this mess. So you know a cake is out there, somewhere. But you're left with no recipe, no actual cake to eat, just the messy evidence that something happened.
And you can imagine, this logical mess leads to some really big questions. We've got to interrogate the proof itself. If it doesn't actually hand you the thing it's proving, does it even have any real meaning? Can we actually trust it? Yeah, this is really where the modern investigation kicks into high gear. Logicians started asking some pretty deep questions, like, does a non-effective proof have any real-world meaning at all? Or, and this is the cool part, what if the witness isn't really gone? What if it's just hidden, locked away somewhere deep inside the proof's own logic? And if that's the case, could we, find a key? Could we actually invent a way to extract that implicit witness? And the answer, which is just amazing, is yes, we can. This whole line of questioning led to the development of what I like to call the Logicians Forensic Kit, a whole set of incredibly powerful tools designed specifically to crack these non-effective proofs wide open and pull out the hidden information. And this toolkit is pretty incredible, filled with all sorts of advanced, powerful techniques. You've got things like proof mining, functional interpretation, negative translation, the list goes on. For our investigation today, though, we're just going to focus on two of the biggest, most powerful tools in the entire kit. All right, let's look at tool number one, proof mining. And this is where things get really, really clever. See, when you use proof mining on one of these mysterious proofs, it doesn't just find the missing witness and hand it over to you. No, it does something way more subtle, and in a lot of cases, something just as useful. It finds the fence around them. Just think about that. It's like proof mining might not be able to point to the exact person you're looking for in a giant crowd. But what it can do is draw a big circle on the ground and tell you with absolute certainty, okay, whoever you're looking for, they are somewhere inside this circle.
It essentially extracts effective bounds from these seemingly useless proofs.
And that transformation is it's incredible. You go from this really vague, almost philosophical statement, like, yeah, a solution exists, somewhere out there, to something totally concrete and useful. Something you can actually work with, like, okay, we can now guarantee that a solution exists somewhere between the numbers 5 and 10. All of a sudden, our giant mystery has a very small, very well-defined search area. It's a game changer. But, what if we want to do more than just narrow the search? That's great, but what if we could build a machine that actually finds the witness for us? Well, that brings us to our second and arguably even more powerful tool. This next tool is called functional interpretation. And look, if proof mining is like a detective drawing a chalk outline around the crime scene, then functional interpretation is like building a time machine that can replay the entire event and point directly at the culprit. What it does is it translates the abstract, high-level logic of the proof into a concrete, runnable computer program. So here's how this incredible machine works. It's basically 3 steps. Step 1, you take your non-effective proof, the one that tells you a witness exists but has no idea where, and you feed it in. Step 2, the machine gets to work, processing the proof, translating every single logical step. And then step 3, the output. What comes out the other side is something called a functional, which for our purposes is basically just a computer program. And when you run that program, it spits out the missing witness. It actually finds it and gives it to you.
And this is the part that is it's truly mind-bending. What logicians figured out is that the proof itself, even one of these weird, non-constructive ones, already contains a hidden algorithm. The proof is the program. It's just written in the language of pure logic instead of Python or C++. Functional interpretation is basically the Rosetta Stone that lets us translate it into a language a computer can understand. So, what's the final verdict in our case of the missing witness? Well, it turns out the witness was never really missing at all. It was there the whole time, just hidden, encoded deep within the very logic of the proof itself. And that's the big takeaway here. This is so profound. It means that even the most abstract philosophical proofs are secretly just brimming with concrete computational information. They aren't just statements that something is true. They are literally a set of instructions for how to find that truth. And that leaves us with one last, really fascinating question to ponder. If a mathematical proof, the very symbol of clarity and explicit logic, can hold these deep, hidden computational secrets, well, it makes you wonder, doesn't it? What other fundamental ideas are we looking at every single day, completely unaware of the secrets hidden just beneath the surface? What else are we missing?